the universe is not expanding. Everyone told you the universe is expanding. Your teacher said it. Science documentaries said it. Neil deGrasse Tyson said it on every late-night show for 30 years. And it's the Big Bang, the expanding cosmos, galaxies racing away from each other at unimaginable speeds. It's the foundation of modern cosmology. And it's the thing every person learns when they first get curious about the universe. And it is not the full story, not even close. I'm Leonard Susskind, and I've spent over 50 years working in theoretical physics. String theory, black holes, quantum mechanics, the structure of space-time itself. And what I'm about to tell you is something that most physics communicators deliberately avoid, not because it's wrong, but because it breaks something in the mind that's very hard to put back together, the universe expanding that phrase the way it's taught, the way it's visualized. And it's the mental picture every person carries. It is built on a confusion so deep, so fundamental, that when you finally see it clearly, you will question every cosmological statement you've ever accepted. And stay with me, because this is going to take something from you and give you something much larger in return. Let me start where the story starts. And in 1929, Edwin Hubble made an observation that changed everything. He measured the light coming from distant galaxies and found something strange. And the light was shifted toward the red end of the spectrum. Red shifted, and the further away the galaxy, the more red shifted the light was. This is called Hubble's law. And the interpretation physicists settled on was that these galaxies are moving away from us. The further they are, the faster they recede. And the conclusion everyone drew was simple. The universe is expanding, galaxies flying apart, space itself stretching like the surface of a balloon being inflated. That's the image. And that's what every documentary shows you. The balloon with dots on it, dots moving away from each other as the rubber stretches. Beautiful image, wrong in a way that matters more than you think. And here's the first thing nobody tells you. The galaxies are not moving through space away from us. Space itself is expanding between us and them. This sounds like a minor distinction. It is not. It is the most important distinction in cosmology, and most people, including most people who consider themselves science literate, do not understand what it actually means. And when you throw a ball, the ball moves through space. It has a location. It changes location over time. That's motion, normal motion. And it's the kind of motion that obeys the cosmic speed limit, the speed of light. Nothing can move through space faster than light. This is one of the most tested facts in all of physics. But the expansion of the universe is not motion through space. It is the expansion of space itself. And space expanding is not subject to the speed limit. This is where it starts to break. And right now, as you watch this video, there are galaxies so far away from us that the space between us and them is expanding faster than the speed of light, not the galaxies moving faster than light, and space itself growing faster than light. The galaxies are essentially stationary in their local region. But the metric, the fabric of space-time between us and them, is expanding so rapidly that they are receding from us at superluminal speeds. We call these galaxies beyond our cosmological horizon. And we can never see them. No light they emit today will ever reach us, not because it isn't fast enough, but because the space it would have to cross is expanding faster than the light can cross it. And think about that right now. There's more universe than we can ever observe, not just more than we've looked at, more than we could ever look at, more than we could ever receive any signal from, and regions of space-time that are causally disconnected from us forever, not because they're hidden, but because the geometry of the universe puts them beyond any possible horizon. And that's just the beginning of why the universe is expanding, is not the statement you think it is. Here's the second thing they don't tell you. And when cosmologists say the universe is expanding, they are working within a framework called the Friedman-Robertson-Walker metric, and a mathematical description of space-time that assumes the universe is homogeneous and isotropic, roughly the same in all directions, roughly the same everywhere. And on the very largest scales, this is approximately true. Galaxies cluster, but averaged over enormous volumes, matter is distributed roughly uniformly. And in this framework, the expansion is described by something called the scale factor, a single number that describes how big the universe is relative to some reference time. And as the scale factor grows, distances between things that are not gravitationally bound to each other increase. That is what we mean by expansion. But here's what that actually implies that nobody talks about. The expansion is not happening everywhere inside this room. The universe is not expanding inside our solar system. The universe is not expanding inside the Milky Way galaxy. The universe is not expanding inside the local group of galaxies, including Andromeda and the dozens of smaller galaxies gravitationally bound to us. The universe is not expanding. Gravity at the local scale wins. And gravity holds things together. The expansion of space is a large-scale statistical effect, visible only when you average over regions so enormous that local gravitational structures become irrelevant. And on any scale that we as humans actually interact with or could ever interact with, the universe is not expanding. The expansion is real, but it is a statement about the very largest scales. And when you imagine it as galaxies flying apart through empty space, you're imagining something that the mathematics does not actually describe. And now, I want to tell you something that should stop you cold. In 1998, two teams of astronomers made a discovery that won the Nobel Prize in Physics in 2011. And they were measuring distant supernovae, type Ia supernovae, which are remarkably useful because they always explode at roughly the same brightness. And by comparing the apparent brightness of these supernovae with their redshift, you can measure how the expansion rate of the universe has changed over time. And what they found shattered the model everyone had been working with. The expansion of the universe is accelerating. Not slowing down, not coasting, accelerating. The universe is not just expanding, it is expanding faster and faster. The scale factor is not just growing. The rate at which it grows is growing, and this acceleration is not explained by anything in the standard model of physics. And it requires something new, something nobody has ever directly detected, something we call, for lack of any better understanding, dark energy. Dark energy. And so, name that sounds like it belongs in a science fiction film, but the name is not the problem. The problem is what dark energy implies. And if dark energy is real, and the evidence that something is causing accelerating expansion is overwhelming, then approximately 68% of the energy content of the universe is made of something we cannot see, cannot detect, directly cannot produce in a laboratory, and do not understand 68%. Most of the universe, most of everything, is made of something we have no theory for. We have a placeholder, we call it the cosmological constant, and Einstein actually introduced the cosmological constant in 1917 when he thought the universe was static as a term to balance gravity and keep everything from collapsing. And when Hubble showed the universe was expanding, Einstein called the cosmological constant his biggest blunder. He removed it from his equations, and then in 1998 it came back. The data demanded it, and something in the equations of general relativity had to produce accelerating expansion, and the cosmological constant was the simplest mathematical choice. But what is it physically? Nobody knows. And the most natural interpretation from quantum field theory is that dark energy is the energy of the vacuum itself, empty space. The quantum vacuum is not empty, and it seethes with virtual particles constantly fluctuating in and out of existence. These fluctuations should contribute energy to the vacuum, and that vacuum energy should act exactly like a cosmological constant, pushing space apart. Here's where it becomes almost unbearable. And so when physicists calculate the vacuum energy using quantum field theory and compare it to the measured value of the cosmological constant, they get a number that is off by a factor of 10 to the power of 120. Not 10 times off, not 1,000 times off. 10 to the 120. That is a 1 followed by 120 zeros. And this discrepancy between the theoretical prediction and the observed value is the largest discrepancy between theory and observation in the history of physics by an almost incomprehensible margin. And it has been called the worst prediction in physics. Some physicists call it the vacuum catastrophe. We know something is causing the universe to accelerate. We have a name for it, and we have a mathematical term for it. We have precisely zero understanding of what it actually is, and the universe is expanding because of it. Let me now take you somewhere even more disorienting. And the question of whether the universe is expanding depends on how you define the universe. And this sounds like philosophy. It is not. It is extremely precise physics. And if the universe is finite, if it has a total size, then expanding means its total size is growing. And if the universe is infinite, then it was already infinite at the Big Bang, and it is still infinite now. And what is growing is not the size, but the scale, the distances between things. An infinite universe that doubles in scale is still infinite. It occupies the same amount of nothing as before because infinite times 2 is still infinite. And we do not know if the universe is finite or infinite. Every observation we can make is limited to the observable universe. And sphere roughly 93 billion light years across, centered on us, defined by how far light has had time to travel since the Big Bang. And beyond this sphere, we see nothing because light from further regions hasn't reached us yet. The observable universe is finite by definition. The total universe may be far larger, possibly infinite. And the latest measurements of the cosmic microwave background radiation suggest the universe is spatially flat or very close to it. And flat universe in the context of general relativity is consistent with being infinite. It doesn't require infinite, but it permits it. And if the universe is infinite, then the statement "the universe is expanding" requires extremely careful interpretation. What is growing is a local scale factor, and what is changing is the metric, the measurement of distance, the content of the universe. The stuff, the galaxies, the clusters, the voids extend forever, and they always have, and they always will. And there was no moment when everything was packed into a small space and then exploded outward. The Big Bang was not an explosion in space. And it was a moment of very high density distributed across an infinite or very large spatial volume where the scale factor was small and the universe was hot and dense everywhere, including regions we can never see. And then that scale factor grew, not exploded outward from a point, expanded uniformly everywhere simultaneously. There's no center of the expansion, there's no edge moving outward, and there is no outside of the universe into which it expands. The universe expanding does not mean it is getting bigger in some larger container. There is no container. And space-time itself is the thing. And the thing is changing its internal geometry. This is not what the balloon analogy shows you. The balloon has an outside, and the balloon expands into the air in your room. The universe does not do this. There is no room. There is only the balloon, and the balloon is not the surface of the balloon. And it is the material of the balloon itself, three-dimensional, possibly infinite, expanding uniformly in all directions with no center and no edge. And if your mental model of cosmic expansion has a center, it is wrong. Now, let me tell you the part that truly keeps me awake. And when we observe the expansion of the universe, we are not observing the present universe. We are observing the past. And the light from a galaxy 1 billion light years away left that galaxy 1 billion years ago. It has been traveling through space for 1 billion years before it reached our telescopes. And the galaxy we see is not where that galaxy is now. It is where that galaxy was 1 billion years ago. And the universe we observe is a layered record of different eras, all compressed into the single image we see when we look at the sky. Nearby galaxies are recent, distant galaxies are ancient. And the cosmic microwave background radiation, the faint glow of microwaves that fills the universe uniformly, is the oldest light we can see. And it was emitted approximately 380,000 years after the Big Bang, when the universe cooled enough for atoms to form and the universe became transparent. And what we see when we look at the cosmic microwave background is the universe as it was 13.8 billion years ago, minus 380,000 years. And we cannot see earlier than this, before this moment, the universe was opaque. Light couldn't travel. And the early universe was a plasma, a hot, dense fog of protons and electrons, and photons bounced around inside it endlessly without escaping. The Big Bang itself is invisible to us. And not because it was small, because the physics of that early universe makes it opaque. And we are surrounded by the last scattering surface, the moment when the universe became transparent, like a fog bank that marks the edge of visibility. Beyond it, we cannot see, not with light. And so when we say the universe is expanding, what we actually observe is a series of snapshots of the universe at different times, each snapshot taken from a different distance and therefore a different moment in the past. We assemble these snapshots into a coherent picture using general relativity. And the picture tells us the universe was denser in the past and the scale factor was smaller, and it has been growing ever since. But we have never observed the universe right now. We cannot. And the speed of light prevents it. The universe we see is always a reconstruction, always a map drawn from ancient light. And the actual present state of the cosmos is, in a very precise sense, unknowable to us. There is a version of the universe happening right now that we will never see the present universe. And galaxies that have merged or exploded or collapsed since their light left them, stars that have formed and died, planets that have appeared. And whatever's happening right now at the locations of those ancient galaxies we observe is hidden from us not by distance alone, but by the fundamental limit of how information travels through space-time. The universe we observe is a ghost, a record of the past, an archaeology of light, and it is expanding. In the past, it was smaller. In the future, it will be larger. And the galaxies we currently observe will one day, billions of years from now, have their light so redshifted and so diluted by the expanding space between us that they will vanish from our observational horizon. Future civilizations, if any exist, will see a darker, lonelier sky. Fewer galaxies, less light, more isolation. The accelerating expansion means this process compounds. And dark energy is pushing space apart faster and faster. The galaxies already beyond our cosmological horizon recede faster every year, and slowly, very slowly by human timescales, but inexorably by cosmic ones. Galaxies that are currently just inside our horizon will cross. It will become unreachable. Their light will never arrive. And the observable universe is shrinking, not because the universe itself is getting smaller. The universe is getting larger. But the portion of it we can ever observe, ever receive information from, ever interact with, is shrinking. And the expansion of space, driven by dark energy, is slowly cutting us off from more and more of reality. And billions of years from now, if something resembling a civilization still exists in what is now the Milky Way, the sky will look almost empty, and the nearby stars of our own galaxy will remain bound by gravity, immune to cosmic expansion. But the vast sea of galaxies we can see today, the billions of galaxies in the observable universe will be gone, receded beyond the horizon, invisible, inaccessible, not destroyed, just unreachable. And the universe is expanding, and in doing so, it is slowly erasing itself from our view. I want to come back to the question I raised at the beginning. And the universe is not expanding the way you think it is. It is not galaxies flying through space away from each other. And it is space itself growing in a universe that may be infinite, driven by an energy we do not understand, visible to us only as an ancient historical record, because the speed of light limits what we can observe. The expansion has no center, no edge, no outside. It is not happening at the scales we live at. It is not happening inside galaxies or solar systems or planets. And it is a property of the very largest scales of reality. And it is accelerating in a way that cannot be explained by any known physics. This is not a critique of cosmology. And cosmology is one of humanity's great achievements. The evidence for cosmic expansion is extraordinary. The precision of our measurements is staggering. And so we have detected the faint pattern of density fluctuations in the early universe imprinted on the cosmic microwave background with enough detail to determine the age, composition, and geometry of the universe to several decimal places. But precision of measurement is not the same as depth of understanding. We measure the expansion, we model it with remarkable accuracy. And we cannot explain the thing driving it. Dark energy is real in the sense that something with its mathematical properties must exist to account for what we observe. And dark energy is mysterious in the sense that we have no physical theory of what it actually is. And the discrepancy between the quantum field theory prediction and the observed value remains the most embarrassing failure of theoretical physics. 70 years of quantum mechanics and 50 years of the Standard Model, and we cannot predict the energy of the vacuum to within 120 orders of magnitude, and the universe is expanding because of it. And here's what I find most extraordinary about all of this. And so we are on a small planet orbiting an ordinary star in an unremarkable spiral galaxy, among hundreds of billions of galaxies in an observable universe that is itself a small fraction of the total universe, which may be infinite, which is accelerating in its expansion, driven by an energy we cannot explain, and from which more and more of reality is being hidden from us as space expands faster. And thin light can cross it. And we work this out, sitting on this small planet, using mathematics and telescopes, and the discipline of controlled observation. And that is perhaps the most astonishing fact in all of this. Not that the universe is expanding, but that beings made of atoms living on the surface of a rock surrounded by an ocean of darkness they can barely see into managed to reconstruct the geometry of the cosmos from first principles and precise observation. We are, as far as we know, the only part of the universe that understands itself. That should not be a source of arrogance, it should be a source of responsibility. And because if the universe is expanding, and if dark energy continues to accelerate that expansion, and if the observable universe continues to shrink, then the record of what is happening right now, the light, leaving galaxies today, will eventually be lost, not to ignorance, to geometry. The expanding space will carry it beyond any possible horizon. The universe is writing its history in light, and light can only travel so far. Everything we do not observe now, we may never have another chance to observe. The window is not closing quickly, but it is closing on timescales of billions of years. The universe is becoming a smaller and smaller observable place. Not because it is contracting, but because it is expanding too fast for its own light to keep up. And the universe is not expanding the way you think it is. It is doing something stranger, something more extreme, something that the word expanding cannot fully contain. It is geometry changing and scale transforming, and space itself growing in a process that has no analogy in ordinary experience, driven by an energy that represents the single largest gap between what we predict and what we measure in all of scientific history, visible to us only as ancient light decoded by mathematics, and accelerating in a way that will eventually leave the universe in the deep future almost entirely invisible. Hence, what you call the expanding universe is actually the universe slowly disappearing from view, and the only reason you know any of this is because you're here now. And in the narrow window of cosmic time, when enough of the universe is still visible to figure it out, look up at the night sky. Every galaxy you can see in a telescope is a message from the past. And it's ancient light that crossed billions of light years to reach your eye. The universe in its present state, right now at those locations, is hidden from you. The expansion is carrying it away. And the future is darker than the present. But you are here in the moment when the universe is still visible enough to understand itself. That is not nothing, that is everything.